Hi everyone, myself Rajeshwari, working as an assistant professor in Marri Laxman Reddy Institute of Engineering and Technology in Civil Department. Today we'll discuss about the subject of ARCD. ARCD is abbreviation is Advanced Reinforced Concrete Design. So these are all the core objectives of the ARCD subject. First one, to understand the concept of limit state design. Second is to understand the various types of loads in current codes of practice for the design. Third one is to understand the design concept of structural elements. Last one is to analyze and design advanced structural elements. These are all the course objectives. Next, we are going to the course outcomes. After completion of the course, students should able to first one explain the concept of limit state design. Second one, understand and explain the analysis of advanced structural elements. Third one is apply the codal provisions of different limit states. Fourth one is design advanced structural elements. These are all the course outcomes. This is the syllabus in ARCD subject. Unit number 1, limit state analysis of RC structures. So in that subtopics are included in this subject. So loads, different types of loads, different methods are all are subtopics in this first unit. Next we are going to the unit number 2, limit state of flexure. IS code provisions, loading patterns, bending moments, envelope applications for fixed beams and continuous beams, D beams and curves. These are all the subtopics in unit number 2. Is the unit number 3, inelastic analysis of slabs. Then in the subtopics are involved in this unit number 3, the ribbed slabs and flat slabs. Next, unit number 4, limit state of shear, bond and torsion. Design for shear, bond and torsion, mechanism of shear and bond failure, design of shear using limit state concept, design for bond, anchorage and development, length of bars, design of section for torsion, detailing of reinforcement. Next, unit number 5, limit state of compression, design of short and long columns, slenderness limits, methods of design of slender columns, additional movement methods, procedure for design of slender columns. These are all the syllabus in the ARCD subject. Next, we are going to the topic of methods of RC design. So methods of RC design, there are 3 types is there. The first one, working stress method. The second one, limit state method. Third one is the ultimate load method. So first and now I am explaining to the first one, working stress method. In the working stress method, this method of design was the oldest one. So in that method, consider the strength point of view. It is based on the elastic design. Assume that both concrete and steel act together and remain perfectly elastic at all stages. The modular ratio can be used to determine the stress in concrete and steel. So design stress is our permissible stress is equals to characteristic strength of material by factor of safety. In this working stress method, we have to take the value of factor of safety for concrete is 3 and steel is 1.78. Working stress method, WSM is the traditional method of design. Nowadays, it is only used in design of water tanks, chimneys, other leak-proof structures. Next method is ultimate load method. This is also known as load factor method or ultimate strength method. In this method, ultimate load is used as the design load. Ultimate load is obtained by multiplying the working load with the load factor. So consider non-linear behavior of the material. This method gives very thin sections. Load factor depends on the load combinations. So load factor is equals to ultimate load by working load. In this method, factor of safety values taken from the concrete is equals to 1.5 and steel is equals to 1.5. Next method, limit state method. In this method of design, a structure shall be designed to withstand the safely all loads liable to act on it throughout its life. It shall also satisfy all serviceability requirements such as limitation of deflection, cracking, etc. This method is advanced over traditional design methods. It is a plastic design method. The acceptancy limit for safety and serviceability requirements before failure occurs is called as a limit state. So, in this limit state method, consider safety, ultimate load, serviceability is a working load. Types of limit state methods classified into two types: limit state of collapse and limit state of serviceability. In the limit state of collapse is a flexure, shear, compression, torsion. Next, limit state of serviceability. Next, now I am explaining to the singly reinforced beam. So, what definition of beam? Beam is a horizontal structural member which carries a transverse shear load. This is the beam. Okay. So, load is applying like this. Okay. So, this load transferred to the slab, beam, columns and totally transferred to the foundation. So, what is the beam definition here? Beam is the horizontal structural member which carries a transverse shear load. Total load transferred to the foundation. So, beam is a rectangular in a cross section. So, beam carries the floor, slab or the roof of slabs. So, beam transfers all the loads, includes itself to the columns or walls. So, next we have discussed about the singly reinforced beam. The beam that is longitudinally reinforced only in the tension zone is known as a singly reinforced beam. Example, we have to take the beam. So, this is the breadth. So, some bars provided only tension zone. So, this is D dash. This one is the D. So this is the neutral axis N, A. So, example, total distance of this is the overall D. So, bars are, it's a neutral axis, above is the compression zone, below is the tension zone. So what is singly reinforced beam here? Bars are provided only in tension zone, that is called as a singly reinforced beam. Example like this. So, in such a beams, the ultimate bending moment and the tension due to bending are carried by the reinforcement, while the compression is carried by the concrete. Practically, it is not possible to provide reinforcement only in the tension zone because we need to tie the stirrups. So, next, design procedure of singly reinforced beam. This is the beam, stress block parameters. This is the beam. So, like this example, this is a cross section of the beam, strain diagram and stress distribution diagram. So, this is stress block parameters. So, design procedure of singly reinforced beam. So, using limit state method, we have to design the singly reinforced beam. So, what are the steps are included in the design procedure? We have now I am explaining. So, step 1 is cross section dimensions. So, in this subject, we have to use code book. So, what is the code? IS 456 2000. This is the code book used for IRCD subject. IS means Indian Standard. So, now I am explaining design procedure of singly reinforced beam. What is the step 1 here? Cross section dimension. So, the depth of the beam is fixed based on the span by depth ratio to satisfy the deflection requirements. Reference, we have to take the code book for IS 456 2000, clause number 23.2.1 and page number 37. So see the code book, take the span by depth ratio values. So we need to find find out the effective depth is equals to span by depth. We can get effective depth. Next, effective span L. So we have to draw the beam. This is the clear span. This is the effective span. What is the topic here? Effective span L. So finally find out effective span L. First, L is equals to clear span plus effective depth. This is the clear span. Already we need to find out depth here. So add the depth, we can get L. So next we need to find out again L, clear span plus center to center support of distance. This is the thickness of wall thickness, like example 200 mm. So clear span plus, so clear span example L plus 200. So 200 by 2 plus 200 by 2, we can get L. So find out these two values. We have to take the value of smaller one. So whichever is less is taken as the effective span. So this is the table. So span by depth ratio values according to the beam, we have to take the span by depth ratio values, serial number, span range, loading type, span by depth ratio. So span is already given in a question. Span 2 to 4 meters is given in a question. We have to take the span by depth values 15 to 20. So next in the question, so clear span is given in 5 to 10 meter in between. So loading type is medium to heavy. So span by depth values taken, we have taken 12 to 15. So next, greater than 10 meters span given in a question. We have so loading type is heavy, span by depth ratio values we have taken the 12. So then after we can get L. Next, going to the step number 2, loads. So we have to take now we have to do the design procedure of singly reinforced beam. Any load acting on a beam we have to consider as loads calculation. That is the step number 2. So step number 2 is the loads. First, now we have to do the design of singly reinforced beam. First we have to calculate the self weight of the beam. So self weight of the beam is equals to area of section into unit weight of RCC. Area of section is, this is the beam now, so B and D. So we have to take the cross sections B into D into 1 into 25 unit weight of RCC. So any live load is given in a question, we have to take the live load. So finally find out the total load is denoted by W is equals to self weight plus live load, we can get total load. Then next, design ultimate load, W suffix U is equals to PSF into W. PSF means partial safety factor. Where? So in that unit weight of RCC, we have to take the value of 25 kilonewton per meter square. Partial safety factor is equals to 1.5. That is the step number 2. Next we are going to the step number 3, ultimate movement and shear force. Ultimate movement mu is equals to WL square by 8 and shear force VU is equals to WU L by 2. That is step number 3. Next step number 4, tension reinforcement. So manaki tension reinforcement, types of steel. First one, mild steel. Second one, HYSD steel. The third one is TMT bars. So these are all the types of steel. Mild steel and HYSD, high yield strength deformed bars. TMT means thermomechanically treated bars. So in that step number 4, tension reinforcement, there are 3 grades of steel here. So that is FE 250 and FE 415, FE 500. So take the formulas from FE 250 is equal MU limit is equals to 0.49 FCK BD square. FE 415, this is a grade of steel, is equals to 0.1 MU limit is equals to 0.138 FCK BD square. Next, what is the last grade of steel? FE is FE 500. So if MU limit is equals to 0.133 FCK BD square. FE is a ferrous. Okay. Next, these are 3, then after compare MU is equals to MU limit, that is called as a balanced section. MU is less than MU limit, that is a under reinforced section. MU is greater than MU limit, that is over reinforced section. So then next, moment of resistance, we need to find out moment of resistance, that is M suffix U. What is the formula here? So use the code book IS 456 2000 page number 96. This formula there in page number 96 in your code book. What is you need to find out MU 0.87 FI AST FC AST into D 1 minus FI AST by FCK BD. We can get AST required. Using this formula, we need to find out AST required. So use the code book. Next, minimum AST required. AST is formula is there. AST minimum is equals to 0.85 into B into D by Fy. Fy is the grade of steel. So note, the diameter of hanger bars should not be less than 10 mm and that of main bars taken as 12 mm. The nominal diameter of bars used are 8 mm, 10 mm, 12 mm, 16 mm, 20 mm, 25 mm and 30 mm. So then after we can get AST minimum, then we need to find out a number of bars provided. So in number of bars provided is equals to AST is equals to AST by capital AST by small ast. We can get AST provided. The units are mm square. Next, now we are going to the step number 5. Check for shear stress. Nominal shear stress is equals to tau V is equals to VU by BD, where VU is the shear force due to the design loads, B is the width of the beam, D is equals to effective depth of the beam, tau V is the shear stress, tau C is the design shear stress. Next, we need to find out percentage of tension reinforcement. Percentage of tension reinforcement, PT is equals to 100 AST by BD formula. This formula is present in a code book, table number 19 and page number 75. After the completion of PT, percentage of tension reinforcement, we can get the value of PT. Next, we need to calculate the tau C. We have to take the values from code book and the page number 76, 75, table number 19. M is a grade of concrete is given in a question. According to the grade, according to the PT, percentage of values, we have to take the values. Then after find out the tau C. Then after we have to check the condition. Tau V is less than tau C, hence beam is safe in shear. Next, step number 6, check for deflection control. So PT is equals, what is the condition here? L by D max is equals to L by D basic into KT KC into KF. KT KC KF, three is the modification factors. So first we need to find out Fs 0.58 into F5 into AST required by AST provided. So these are KT figure number 4, figure number 5, figure number 6 in page number 38 and 39 in your code book IS 456 2000. Take the values from figure number 4, figure number 5, figure number 6. That are all the modification factors. Finally, so after completion of this, L by D max is greater than L by D provided. We can get this. So finally, deflection control is satisfied. So last step number 7, reinforcement details in a singly reinforced rectangular beam. This is the beam. So those are all steps. First step number 1, 2, 3, 4, 5, 6. All values we need to find out. That values are present in the diagram. So what is the topic here? Design of singly reinforced beam. So that all values are showing in the diagram. So this is the beam. This is the longitudinal section. This is the cross section. So for example, like. So this is a clear span, this is the effective span. Totally we have to show in the diagram. So this is the final step, reinforcement details in a singly reinforced rectangular beam. So this is bars are provided only, tension zone. This is the last step number 7. Thank you.